Okay, thank you to Kimberly Jean, who is joining us today to help us learn about the mechanical advantage of a bike. And so we're going to look at these examples up here on the screen and see that the mechanical advantage of a bike is increased if the wheel is bigger, because we're looking at the distance pedaled and we're looking at the distance traveled to figure out the mechanical advantage. So let's look at our example. And here we have an example of a big wheel. So here, if we want to calculate the distance pedaled, we look right here and we see the radius of this circle when we pedal is 1. So circumference equals 2 pi r. And so here the radius is 1. So in this case, the circumference is 2 times pi and the radius is 1. That would be the distance pedaled. Now we'll look at the distance traveled. That would be the circumference of the big wheel. So here we see the radius is 4. So the circumference in that case would also be 2 pi r, and the radius being 4, which is 4. So we have 8 pi would be our distance pedaled. So if we want to do our mechanical advantage, we do the distance traveled divided by the distance pedaled. And in this case, our distance traveled is going to be 8 pi, which is the circumference of the big wheel, and the distance pedaled is only 2 pi, which is circumference of the smaller wheel. So the pi's cross out and we have a mechanical advantage of 4. What that means is that you can go 4 times as fast as you can pedal if you're on a big wheel. Okay, so here we see a tricycle, and you see that the pedal is here, so we could also measure the mechanical advantage of this tricycle if we knew the radius of this circle and the radius of the wheel. And that would be a simple calculation. It would just be the same distance traveled divided by distance pedal, and you can see we could also have a mechanical advantage because this circle is smaller than this circle. Now let's look at an example problem where we have Emily's bike. It's a little bit more complicated because we have more circles to consider. So here we have our distance pedaled. In this case, we have 9 centimeters, which is our distance pedaled, which we're going to use that as our radius. And if we have our circumference equals 2 pi r, then our circumference of our distance pedaled is going to be 2 times pi times 9 centimeters. So that's going to be 18 pi centimeters. We're not going to worry about the centimeters though until the end because it's all going to be in centimeters. So let's just say that it's 18 pi is our distance pedaled. So now in order to find our distance traveled, we can't just look at our wheel back here because our distance pedaled and our distance traveled with the wheel aren't going to go at the same rate. So every time this goes around in a circle, we also have this smaller circle here. So we need to know what the circumference is for the smallest circle. So that is going to be 12 pi because it's 6 times 2 times pi. So now we have 12 pi, but it's going here in the chain through a smaller circle. This smaller circle is 2 times 4 times pi, so that's going to be 8 pi. So we have 12 pi of chain going into 8 pi here. So we're going to look at the rate. So if we have 12 going into 8, it's going to go around 1 1/2 times. So for every time this goes around once, this is going to go around 1 1/2 because 8 goes into 12 1 1/2 times. So that's going to be our rate of change here. So now we're going to look at the circumference of our wheel in the back, which is actually going to be telling us our distance traveled, but we also have to multiply that by 1 1/2 because we know for every time this pedal goes around once, this wheel is going to go around 1 1/2 times based on our chain. So let's figure out the circumference of the back wheel, and that's going to be 2 pi r again. So we have 2 times pi times the r, which is 15. So now we have 30 pi. But it's not going to just turn once, it's going to turn 1.5 times. So it's really going to turn 45 pi. So now we can go back and we can get our distance pedaled, which is 18 pi. And that's going to be in our denominator. And our distance traveled, which is 45 pi, is going to be our numerator. So the mechanical advantage of this bike is going to be 45 pi divided by 18 pi. So the pi's cross out.
We could add the centimeters here, but we really don't need to because they would cross out anyway.
And our mechanical advantage is going to be 2.5. What does that mean? That means when Emily gets on her bike, she can go 2.5 times faster than she can pedal. So there are some other problems for you to do with Mariana's bike and with Aldo's bike. And if you really want to challenge, you have Christina's bike.
We have all of these different settings so that we have 7 speeds in the back and 3 speeds in the front, which makes a 21 speed bike. And a 21 speed bike means 21 different mechanical advantages. So I look forward to seeing your work on all these problems, and please contact me if you have any questions. Thank you. Bye-bye.